Wasabi, you guys. Welcome to Integration Bee Training for Advanced, part 13.2. In this section, we'll be dealing with trickier stuff, trickier Weierstrass substitution integrals. So let's go ahead and dive into this. Sine squared plus cosine x plus 1 at the bottom. So, again, we're just going to dive in with u equals tangent of x over 2. Then our dx is equal to 2 over 1 plus u squared du, right? Our sine of x is 2u over 1 plus u squared. And our cosine is 1 minus u squared over 1 plus u squared. Okay? So now let's go ahead and dive in. This is pi over 2. Tangent pi over 4 is 1. So we have 2, 1 plus u squared du. We have 2u, 1 plus u squared, squared. 1 minus u squared plus 1 plus u squared. And plus 1. And if we simplify this, let's actually, because we have 1 plus u squared squared, we're going to multiply top and bottom by 1 plus u squared squared. So what that means is now we have 1 plus u squared here. That's 4u squared. 1 minus u squared times 1 plus u squared is 1 minus u4. And then plus 1 plus u squared squared. So that's 1 plus u4 plus 2u squared. Okay, like I said, a lot of Weierstrass substitution, this is what happens. You convert your ugly trig integral into an ugly rational function. And yes, you will be terrified at first. But just kind of simplify everything, just to make sure. Du, I noticed that negative u4, thank God. So now we have 6u squared plus 2. That cancels our 2, 1 plus u squared, and we get 3u squared plus 1. Alright, here it's simple, you already know exactly what to do, right? You know, u squared plus 1/3, or I guess you could multiply 3 and 1/3, right? You could do 3 1/3 here, and you get 3u squared 1/3, 0 to 1. You get 3u squared plus 1 minus 1. So you purposely made it 1. So 3u squared plus 1 minus 1. 3 minus 1, that's 2. Something like this, right? So your answer is like 1/3 plus whatever this other side is. 2. I'm just lazy. I just don't want to do this. That's all. It should be like 3. Oh no. I'm sorry. 2/3. 2/3. 3 root 3. Did I get another root 3? Is it 3 square? Yeah. Because if I factor it out, yeah. And root 3 inverse tangent of root 3 u. And then from 0 to 1. Okay? And then your answer should be like 1/3 plus 0 inverse tangent of 3. It's pi over 3. Pi over 3 is 2 pi over 9 root 3. I think that's my answer. Yeah. Okay. So again, a lot of the times, Weierstrass, you just have to deal with this ugliness. Okay? Alright. Next example. Here, this is you know, again, you have some awkward, unusual trig integral. What on earth do I do? Right? There's nothing, you know. I mean, you can manipulate it however you want, but like, good luck. So, what we do is, okay, let's try Weierstrass. So let's go ahead. Assuming we already know the formula, this goes into from 0 to 1, 2, 1 plus u squared du, and then square root of 1 minus u squared, 1 minus u squared, 1 plus u squared, and then we know that the denominator is going to be 1 plus u squared, and that's going to be 1 plus u squared as well, because 1 plus sine of x is 1 plus u squared. Okay? Right, 1 plus u squared plus 2u, that's this. I'm just going by fast. Here, thank God for square roots, because look at this. From 0 to 1, 1 plus u squared, I'm just going to put that down. And then here, this actually simplifies, right? The u squared, we have 1 plus u now. And this 1 plus u squared is 1 plus u squared. That cancels out. And then we have du 1 minus u squared. Oh, would you look at that? We have a trig sub integral. So I'll let u equal sine theta. Then we have pi over 2 to 0. We have 2 cosine theta d theta. Right? Oh, well, that cancels out technically because of the bottom. So we have 1 plus sine theta here. Right. Cool. Speed bash time. Okay. So we have 2, 1 plus s, c squared, 1 minus s when we conjugate. This is now secant square of x minus secant x tangent x. This is now 2 tan x minus secant x, 0 to pi over 2. What do you do? I nearly scared you guys, but this is actually okay. You could actually rewrite this as cosine of x, sine of x minus 1. Okay? Don't freak out. Okay, because now you just take it as a limit, right? L'Hopital's rule, right? This should just be, what, cosine, that's like 0. So plug in pi over 2, I think everything equals to 0. Plug in 0, you get, well, 1, but times 2. So the answer is 2. So the answer to this integral is just 2. Okay? Cool. Right. A little scary, like I said. A lot of Weierstrass substitution. It's scary, but it nicely cancels out. And then this whole speed bashing process with a scary limit. Alright, we have this integral here from 0 to pi, 3 plus cosine of x over 2 minus cosine of x. Alright, let's go ahead and use Weierstrass substitution. We have 0 to infinity, because that's tangent pi over 2. 3 plus 1 minus u squared plus u squared. 2 minus 1 minus u squared, 1 plus u squared. And then, of course, we have 2 du, 1 plus u squared. Let's put that aside. I want to simplify this portion here. This will give me, what, 3 times 1 plus u squared. It's going to be, oh, well, the u, oh, no, it's not going to cancel out. 3u squared minus, so it's 2u squared, and 3 plus, what, so it's going to be like 4? 2u squared? Wait, you know what, let me write this down, just to be safe. 3 plus 3u squared plus 1 minus u squared. Right. And then we have 2 plus 2u squared minus Be very careful. This is -1 plus u squared. Okay. Nasty. Alright. So now let's simplify this. We have 2u squared plus 4. Okay, so I was right. And then 3u squared plus 1. Oh, God. Okay. And then times 2 du 1 plus u squared. I honestly don't want to do this, but if you were given this integral in an integration bee, I'm very, very sorry. But u squared plus 2 du. This is 3u squared plus 1 plus u squared. Wow. Jesus Christ. I mean, I don't know if there's a shortcut to this. I mean, if you let u equal tangent theta. Oh God. What secant? Yeah. Secant square. Yeah, you're stuck either way. You're stuck with partial fractions. Yeah. Well, that's awful. You're stuck with partial fractions either ways. Yeah. Alpha, use dummy variables from the beginner training, and then simply 3 alpha plus 1 plus alpha, and then alpha here, alpha plus 2, -1, -1, it's 1, -1, -2, right, -1/3. Oh, it's horrible. It's god awful. This is god awful. Yeah. This is from Gmain, and they have no mercy with all this. But you get the idea. You do partial fractions, and then you have to suffer your way out. Okay. Your answer, if you actually do fully solve this, your answer should come out as 5 pi over √3 minus pi. That should be your answer. Okay? It would have been so nice if that cosine of x wasn't there. It just wasn't there. Right? But unfortunately, it just had to be. So, yeah. Well, Weierstrass it is. So, when we Weierstrass, what we have left is, oh God. Well, let's first cancel out 1 plus u squared. So we have 1 minus u squared minus 2u, minus 2u. And then sine x plus 1, that's going to give us 1 plus 2u plus u squared. But I'm going to leave it like that. Plus 1 minus u squared. Okay. And then we also have cosine 1 minus u squared times 2 from the du, 1 plus u squared squared. Oh God. Okay. So we have 1 minus u squared minus 2u. I don't even know what to do with this. And 1 minus u squared times 2. That is a god awful fraction. And then the u squared cancels out, thank goodness. So we have 2, 1 plus u. Alright. Quite nice. 2 cancels out. This 1 plus u can be cancelled from this, so now we have 1 minus u. Okay. What now? What do we do now? So if we express this, which I honestly don't want to, but we're gonna have to anyways. So 1 minus u times 1 minus u squared minus 2u. This is gonna give us 1 minus 3u plus u squared plus u cubed. Oh God. I already hate it here. I already hate it here. So you get the idea. You know, manipulate. I see 1 plus u squared here, so this is 1 plus u squared. U cube plus u minus u. I'm probably gonna have to do that, right? U yeah, this whole partial, it's disgusting. I'm honestly already unmotivated. You see why I don't like this technique. It's so tedious and disgusting. Yeah, I would never ever throw this at integration B. This is oddly this is god awful. Yeah. We could actually leave it like this, actually, and then let u do w equal u squared. I'm sorry, u squared plus 1. That's where I got it. W minus 4. Okay, and now you can go ahead. So yeah, it's awful, tedious, but yeah, this is realistically Weierstrass. Okay, let's go on for the last integral example. ln of secant x plus tangent x. Huh. What do we do here? What happens if I let u equal ln of secant x plus tangent x? Because I don't want to do integration by parts, because that's cosecant x. So e to the u equals secant x plus tangent x. Okay, but what do I do with the sine x? How do I find sine of x? Right. How do I find that? What is this? Cosine 1 plus sine of x? Dang. Yeah, there's no way for me to manipulate this. So I can't use the secret secant trick. Huh. Well, when in doubt, Weierstrass. So we have I don't know why I put pi. This should be 1. Okay. And then ln 1 over cosine, so it's 1 plus u squared 1 minus u squared. Oh, this is disgusting already. Tangent of x, this is 2u 1 minus u squared, because the 1 plus u squared cancels out itself. And then sine of x, this is 2u 1 plus u squared, while this is 2 du 1 plus u squared. So that cancels out. That 2 cancels out. Wait a minute. Huh. This looks oddly familiar. 1 plus u squared 1 minus u squared over u. This is equal to ln of 1 plus u 1 minus u. Wait a minute. What is this? Would you look at that? This is 0 to 1 ln of 1 plus u of u minus ln of 1 minus u over u du. Ah, who would have thought this becomes a Taylor series integral? Right. Cool. So now, I mean, it's so common, I kind of memorized this by heart. So this is what? Pi square over 12 plus pi square over 6. So this whole integral equals to pi square over 4. Okay? When you do the whole Taylor series stuff, it should come out as pi square over 4. So this integral here is equal to pi square over 4. Very tricky. Again, like I said, Weierstrass is scary, right? When in doubt, when you're dealing with a very awkward, unusual trig integral, Weierstrass. Okay, especially inside of ln, like this is terrifying. We would just hesitate and like not continue, but yeah, this comes out nicely. All right, that is it for Weierstrass. So again, practice and get comfortable with Weierstrass substitution. So I hope this helps. Thank you so much for watching, and I'll see you guys in the next part.